Good morning, gentlemen. I hope you had a good weekend. From the looks of it, everybody pretty much got the hang of it of what to do when you're scalar multiplying a matrix, how to add and subtract a matrix. So today is a little bit different. It can get a little bit confusing, a little bit more complicated on how to multiply matrices. All right. So I need you to pay close attention. Uh, but first, let's start off with these quick problems, right? So it says have A, which is a 3 by 3, B is a 2 by 2, and C is a 2 by 2, right? And the first one's telling me that A plus B. So we know this is a 3 by 3, and this is a 2 by 2, and this is a 2 by 2. All right, so A plus B, can I add two matrices of different dimensions? No, so all you have to do is not possible. And then B plus 2C, so I'm going to have 5, 6, that's a 9. Let's fix that. 9 and 10. Alright. Plus 2 times 1, 2, 1, 2. So I'm going to rewrite this. So I have 5, 6, 9, and 10. Plus 2 times 1 is 2. 2 times 2 is 4. So again. And now I just add them up. So 5 plus 2 is 7. 6 plus 4 is 10. 9 plus 2 is 11. 10 plus 4 is 14. So this is your final answer. I know this is pretty simple, and I'm glad you guys got the hang of it. All right, but this is kind of this is helping you understand of what's coming up. All right. So what is going to happen by a matrix by matrix? All right. So multiplying matrix by matrix. Alright, so the first thing you got to do, alright, the first thing is important. So, how do I know if I can multiply even a matrix by a matrix? Alright, so that means that the column of the first matrix so in other words, the dimension of the column of the first matrix has to match the dimension of the row of the second matrix. So in other words, right? If I have matrix A that is a 4 by 2 matrix and B is a 2 by 3 matrix, then you just put them next to. So if you multiply it, so 4 by 2 times a 2 by 3. So what I need to know when you write it like this is why it's important that you know how to write your matrices. Remember, it's row by column. So I have 4 rows, 2 columns in my matrix A, and 2 rows, 3 columns, my matrix B. So once you figure how to write this down, it's very important. These inside numbers, all right, this too, right there, it's gonna let you know if it's possible. If the inside numbers match, then you're gonna be able to multiply them. If they don't match, then you can't. So if I had a 4 by 3 times a 2 by 3, right? These two numbers inside don't match, so that's when you know you cannot multiply these two matrices. So I need you to be very careful and understand how you write the dimensions of a matrix. Remember, it's row by column, all right? Because in this case, if I didn't know, right, if I gave you a matrix and you put if a 2 by 3 and you wrote it down as a 3 by 2 and you said it's not possible, you're going to get it wrong, which it is possible because the insides number match once you know how to write the dimensions down of a matrix. Okay? Then the next important thing is the row of the first matrix and the column of the second matrix will be the size of your new matrix when you I just put the new matrix. So in other words, if I go back to it, if I have a 4 by 2, right? If I have a 4 by 2 matrix times a 2 by 3 matrix, all right? We know that this match, right? So I know I can do this, all right? So my answer, right? Once I multiply this, my answer is going to be a 4 by 3 matrix, all right? So this is why it's also important that you know how to do it, all right? So here it is. This is telling you the inside tells you if you can do it. The outside's telling you this is the size of the matrix that you're gonna have. And if you get something else, then you know you did something wrong. Okay. So now let's look at this example. All right. Now, before I start off with some examples, I need you to know something. I need you to know that regularly when you multiply something, so let's say 3 times 5, right? So 3 times 5 is equal to 15, right? 5 times 3 is equal to 15, right? These two are associative. That means that no matter what you do, if you put the 3 or the 5 in front, they'll give you the same answer. This is not going to be the same thing for matrices. Alright, A times B does not equal B times A. Alright, so just because once you find the multiplication of matrix A times B, it doesn't mean that B times A is going to be the same thing. And I'm going to show you what I mean by that. So let's look at an example. I'm just giving you a heads up. Example, A is equal to 7, 0, 5, 3, and then B is equal to 3, negative 3, 6, 5, 4, and negative 2, and then C is equal to 6, negative 1, 4, 2, negative 2, and negative 1. Okay, so it's asking me to find A times B. So let's find the dimensions of A. A is a 2 by 2, right? B is equal to a 2 by 3. And C is a what? 2 by 3 as well. Alright? Now, how am I going to multiply this? Alright, just pay close attention. So I'm going to have to grab its row times column. So I write my A. So I have 7, 0, 5, and 3. First off, let's see if do these match. So what I mean is so I have a 2 by 2 times a 2 by 3. Do the inside match? Yes. So that means I can multiply these two. Alright, so I have A, so I'm going to write my A down. So I have 7, 0, 5, and 3 times 3, negative 3, 6, 5, 4, and negative 2. Okay, so this is what I'm going to have to do. Alright, I'm going to grab each row times each column, and then I'm going to add them up. So I'm going to go this row times this column first, and then add them. So what I'm going to do is this is equal to, so I'm going to go 7 times 3 plus 0 times 5. Okay, so I went this one with this one plus this one with this one. Okay, that gave me the next one. Now I'm gonna have to do this every single time. Okay, so I'm gonna get rid of this, that, and that. Okay, now I'm gonna do that next. So I'm gonna grab this 7 and 0, right, times the next column, times this and this. So I'm gonna grab this 7 times this negative 3 plus 0 times 4. Alright, so that's gonna be my next number over. So I'm gonna have 7 times negative 3 plus 0 times 4. Alright, then I'm going to do this again. So I'm done with that one, so I'm going to do this with the next one. So I'm going to have this 7 and 0 times 6 and negative 2. So I have to grab that. So I go, so then it's 7, so this 7 to that 6, and that 0 to that negative 2. So then I have 7 times 6. Oh, let's change the color. Times 6 plus 0 times negative 2. Alright, and then you're going to do the same thing. So now you did the first row times every single column in the second matrix. Okay, so now you got to do the second row times every single column of the second matrix. Alright, so what I did here is what I have to do. What I did to the first row, okay, is what I have to do to the second row. So let me erase this, and this. Alright, so now I'm going to do the same thing, but now I'm going to do it with the second row. I'm going to multiply this times this. I'm going to grab this 5, and I'm going to multiply it by this 3, and this times that. Okay, so I'm going to have 5 times 3 plus 3 times 5. Alright, and then I'm going to do the other one. So once I got that out of the way, okay, so that's a 5. So then I'm going to do this second row times the second column. So I'm going to grab this, this times that, plus this times this. So I'm going to have 5, right, times negative 3 plus 3 times 4. Alright, and then lastly, I'm going to have this times this. So I'm going to have 5 times 6 plus 3 times negative 2. So 5. Oh, let's erase that. 5 times 6. So 5 times 6 plus 3 times 2. Okay, and then you see how this is a 2 by 3 now. So I have 7 times 3 is equal to 21 plus 0, that's just 21. And then 7 times negative 3, that's negative 21. So right here, negative 21 plus 0, that's negative 21. Then 7 times 6 is what? 42. 42 plus 0 times, so this is just 42. Alright, so 5 times 3 is 15. 15 plus 15, that's 30. And then 5 times negative 3, that's negative 15. Plus 3 times 4, so negative 15 plus 12, that's just negative 3. And then 5 times 6 is 30. Whoa, sorry. Five times 6 is 30. And then plus 3 times negative 2, that's negative 6. So 30 minus 6 is 24. Okay? Now, let's find, and this is your final answer, B times A. This right here is your final answer. Okay? I know it can be a lot of work, but it can be pretty simple once you know what you're doing. Once, like everything here in math, the more you practice it, the easier it gets. So let's find B times A, right? So we said the dimension of B was a 2 by 3, right? So 2 by 3. So B is equal to a 2 by 3, and A is equal to a 2 by 2. Now, let's write these down. 2 by 3 times a 2 by 2. Do the insides match? No. So it's not possible. Okay? So this is what I meant, right? Remember what I said, that 3 times 5 is 15 and 5 times 3 is 15? Well, that's associative. That's the same thing. But here in matrices, this is not the same thing, as you can tell, right? So A times B gave me an answer. We just solved it. But B times A gave me not possible because the dimensions of the inside do not match. Alright? So let's do another quick example. I'm going to have a 2 by 2 by 2 by 2. So A is equal to 5, 6, 0, and 1, and B is equal to 4, 2, negative 2, and 3. Let's find A times B. Alright? So that's going to be 1. Find A times B. So all I have to do, so this is a 2 by 2 times a 2 by 2. Okay, so 2 by 2 times a 2 by 2. The insides match. So I know I'm going to be able to do it. So I'm going to do 5, 6, 0, and 1 times. I'm going to do this in a different color. I have 4, 2, negative 2, and 3. So the first row times the first column. I'm going to have this first row times the first column. So I'm going to have 5 times 4 plus 6 times negative 2. Okay, and then I'm going to do the first row times the second column. So I'm going to do this first row times the second column. So I'm going to have 5 times 2 5 times 2 plus 6 times 3, and then I'm going to do that. That's done with that. Now I'm going to go to the next one. I'm going to use the 0 and 1 times 4 and negative 2. So I have 0 times 0 times 4 plus 1 times negative 2. And then lastly, I have my green, so I'm going to do this second row times the second column. So I have 0 times 2 plus 1 times 3. Now if I simplify this, if I keep going, right, I'm going to have, so the first one, 5 times 4 is 20, right? So I'm going to just do it. So 20 minus 12, and then I have 10 plus 18, and I have 0 minus 2, and 0 plus 3, right? So this 20 comes from 5 times 4. This negative 12 comes from 6 times negative 2. This 10 comes from the 5 times 2. This 6 times 3. And the 18 comes from the 6 times 3. The 0 comes from 0 times 4. And the negative 2 comes from 1 times negative 2. Then the 0 comes from 0 times 2. And the 3 comes from the 1 times 3. Alright, so now I just simplify it even more. And I'm left with 8, 28, negative 2, and 3. And this is your answer. So A times B is equal to that. Now, since you saw that it's not possible, let's see what happens when you find B times A. So we said A was, look at my matrix, 5, 6, 0, 1. So 5, 6, 0, 1. And B is equal to 4, 2, 2, 3. 4, 2, 4, 2, 4, 2, negative 2, and 3. Now, B times A. So I'm going to put my B first. So B times A. So I'm going to have 4, 2, negative 2, and 3 times 5. No, let's do this simple. 5, 6, 0, and 1. Right? So then I'm going to grab my first row. So it's equal to my first row times my first column. Okay, so I'm going to have 4 times 5 plus 2 times 0. Alright, then I'm going to do the green. I'm going to go first row times the second column. So then I have 4 times 6 plus 2 times 1. Alright, and then I'm going to do the same thing now with the second row. Second row times the first column, second row times the second column. Alright, so this right here, the second row, so I'm going to do negative 2, right, times 5, and then plus 3 times 0, and then I'm going to do the last one, the second row times the second column. So then I have negative 2 times 6 plus 3 times 1. to simplify it more. So I have 20 plus 0, then 24, 24 plus 2, then I have negative 10 plus 0, then I have negative 12 plus 3, and then I have 20, 26, negative 10, and negative 9. So b times a is equal to this, and then a times b equal to, where is it, 8, 28, 8, 28, negative 2 and 3. So this is an example to show you that 8 times b does not equal b times a. Alright, so this is how you multiply matrix by matrix. Alright, I went as slow as possible. There's 3 examples, so I hope you understand. If you don't, please email me about it and let me know where you're confused, and I'll try to help you as much as I can. Y'all have a great day, and I'll see y'all later.